I want you guys to recall the notes. This is when I created all these notes for statistics students. Okay, here's the notes. There you go. And I want you guys to take a look because remember the binomial situation? Guess what they can ask you? They can ask you for the mean and the variance for a binomial distribution. Okay? So I'm going through those notes. We went through some of these examples already. And down here, what are you guys looking at? Remember that formula that I showed you guys? The mean formula and the variance and the standard deviation? Well, guess what? For the binomial, you have shortcuts. What do you guys see there? What are the shortcuts for finding the mean for the binomial? What does that say to you guys? So I'm going to talk about that. I'm going to go back to the binomial notes. Let's see if I can find them in my binomial. Where are you guys at? Oh, come on. There we go. What class are you guys in? 17041? Yes. There we go. Found them. So if I go to the iPad, and the last kind of examples we worked on was remember this kind of situation? This was a true-false quiz. We did that already in our notes. So here's what I'm going to say to you guys. Let's recall the binomial situation. We could do any one of the situations. We had how many questions were on this last example? 7 questions, and you guys can't see that. Remember the 7 questions on a true-false quiz? You know what they can say to you? What is the expected number of correct guesses on a 7-question true-false quiz? This is the binomial probability distribution. The stuff we worked on. We worked on binomial. We worked on Poisson. We're going to get back to both, but we're going to get back to a situation now. We're going to kick it up. Okay? Now, if I go to my notes, how do we find the mean, ladies and gentlemen? How do you get the mean here? What does it say for a binomial? What's the shortcut? Yes, thank you for reading that. It's n times p. Outstanding, ladies and gentlemen. It's n times p. So you do not have to use the definition. Okay? You just have to know what n is. What is n, ladies and gentlemen? Do you guys remember? 7. Outstanding. N is 7. Good. What is little p? This was the last example. What was little p? You guys remember? Well, a true-false situation. Remember that? 1/2, 0.5. So for the mean, we just have to know n. We just have to know little p. It was pink, though. But now we got red and pink. It was pink. And so can you multiply those two numbers? You guys should be excited. Why should you be excited? Do you have to use this definition? The answer is what? No. You don't. I mean, if you could, but I wouldn't do that. That's like crazy. Just take n. It's 7. Just take little p, 0.5. What is 7 times 0.5? 7 times, let's get out of the, 7 times 0.5. That was your question, so we're good. 3.5? So let's stop and think about this here, because this is important for us, right? Why do I say that this is important? Why is that important? What does this mean? Do you guys know what this means? It's the average. You can expect to get 3.5 questions correct on a true-false quiz. How many questions in the quiz? 7. So you can expect to get half of them right. If you guess, I'm going to say this again. This is insane. If you just guessed, what's the long run average? You're going to get 3.5 questions correct. What do you think about that? If you just guess, how many questions you get correct? 3.5. You know what's crazy? I'm going to tell you guys something. This is kind of interesting. What if you're a student and you took the quiz and you got less than 3.5 questions correct on that quiz? True-false quiz. Because that's what this is. It's a true-false quiz, right? So what if you took that same quiz, but you got less than 3.5 questions correct? Like, let's say you got 2. What does that mean? It means you would have done better if you just guessed. Does that make any sense? So what if you took that quiz, you got only 1 question correct? You would have done better if you just what? Guessed. What's the average number of correct guesses in this setting? 3.5. That is deep. That is, why do I say that's deep? Because you're going to have people who will take a quiz, who will miss everything, or they'll miss less than what is expected, the average. And then you can say, you would have done better if you just guessed on everything. What? Really? Yes. Let's give you guys another example. Remember the binomial? What else did we work on? We did a multiple choice. Is that true? Remember this one? Where is it at? There it is. The 8-question multiple choice quiz. This is now a different example. It's 8 questions now. And what's the deal with this situation? Do you guys remember? How many possible answers are there for each question? 5. Say, how do I know? They told you. So in that example, when we work with the binomial, what was little p? Remember this? It's not 1/2. Remember, for multiple choice, it's not true-false. For true-false, the probability of guessing correct is 1/2. But for a multiple choice, it's not 1/2. What is it? It's 1 in 5. Why is that? Remember, little p is 1/5? Why? Why was it 1/5? There's 1 right answer out of 5 possible answers. So let's do that same analysis, okay? Let's say you and your buddy, you compared test scores. What's the expected number of correct guesses if you guessed on everything? What was it again? NP. In this example, what's this? 8 times 1/5. Was it 1/5 0.2? Yes. And in this example is what? 8. Little p is what? That's not pink. 0.2. In this example, what's the expected number of correct guesses, ladies and gentlemen? What's 8 times 0.2? Do you guys know? What would be that? What would be that answer? 8 times 0.2. We got 8 times 0.2. What's this? 1.6. So what are you looking at now? If you guessed on every question here, how many correct guesses can you expect to get? 1.6. Just by guessing. So if your buddy only got one answer correct by guessing, or 0 answers correct by guessing, what could you tell your buddy? You would have done better if you just guessed. You guys see what I'm saying? You guys see my point? You can get, the average will be about 1.6 correct guesses. That's what can be expected. That's what they call expectation, long run average. It's the same exact definition I showed you guys yesterday. But for a binomial, there's a shortcut. What was the other example we did? Having children. Remember this one? We did this example, having kids. A couple plans on having 8 children. What's the probability of having less than 3 boys? Okay. Let's look at the expected number of boys. Mu is NP because this is a binomial. N, again, is 8. But what's little p in the children setting? Do you guys remember? It's in front of you. It's 0.5. Is that true? Probability of a success for a single trial. So 8 times what? 0.5. So N is 8. Pretty in pink. P, 0.5. And then what's your mu? What's 8 times 0.5? You can expect to have how many boys? 4 boys. That's the average. So the average number of boys in a couple who has 8 children will have 4 boys on average. Half the kids will be boys. The other half will be girls. So the homework on the binomial, let's give you another example. I'm going to write this down, though, in our notes here, okay? See the browser? How do you get the variance? The mean is what? MP. What's the variance? Remember sigma squared? What's that? MPQ? Remember that from yesterday? What was Q? Q, ladies and gentlemen, that was the complement of P, so that's 1 minus P. So I want you guys to know you can use NP 1 minus P for variance. So if I said to you guys, here's an example here. You have a 10 question quiz. Each question has 4 possible answers. Okay? If you guess on each question, what's the expected value? Very easy. Because when you read the phrase expected value, automatically you go, oh, okay, I know the definition. Mu sum x p of x. Okay? Automatically. You guys with me on that? But because this is a binomial distribution, how do you guys know it's a binomial? There's a fixed number of trials. How many trials are there? 10 trials. Remember that number of questions? N. So you go, oh, N is 10. This is a binomial situation because why? There's 2 outcomes for every trial. You can guess what? Correct. Or you can guess how. Incorrect. You're guessing. Okay? You go, how do I know I'm guessing? They just told you. It was written down. You're guessing on each question. Now, how do you find the probability, little p, probability of a success for a single trial? How do you deduce that? You got to read what? There's 4 possible answers for every one of those questions. So if there's 4 possible answers, guessing correct is a success. What's that probability? Nope. Chance of guessing correct. 4 possible answers. So you might say, well, what does that mean? Well, you have a question. A, B, C, D. Right? This is not 5 possible answers. This is 4 possible answers. What's the probability you guess correct? Which one of them is correct? Maybe C. What's the probability of guessing correct? 1/4. There's 1 correct answer out of how many answers? 4. Just like in the last example, there's 1 out of 5 if they told you 5 correct. A, B, C, D, and E. Have you guys ever looked at that before? Right? So if you guess, the chance you guess correct, there's 1 correct answer out of 4 answers. Okay, so what is that as a decimal? So this is little p, the probability of success for your single trial. What does that have to do with our mean? Well, what's the mean formula? It was MP. So what does that mean? 10 times 0.25. What's 10 times 0.25? It's 2.5. So on a 10-question multiple choice quiz where there's 4 possible answers for each question, you can expect to get 2.5 answers correct just by guessing. That's the average. That's the long-run average. That's the summary. This is what we have for expected value when you're in the binomial situation. Yes. That's correct. Only the what? Binomial. You use that for, so in other words, for all the other general distributions, you don't use NP. You know, it's only specifically for the binomial. And in fact, they can say to you, hey, determine the what? Determine the mean and the standard deviation. Okay? Automatically, you go, oh, mean is NP. Well, we just did that one. Mu was 2.5. You say, why? Because n is 10, little p is 0.25. You got a 25% chance of guessing correct on a question. Now, you say, but what if they ask for the standard deviation as well? Didn't we write that down? The variance is what? NP, and then Q. You go, what is Q? Well, ladies and gentlemen, Q is over here. The chance of guessing correct is 0.25. That's little p. Q is the probability of a failure. In other words, it's the complement. So if you say Q is 1 minus the 0.25, you know what that means about Q? Q is 75.75. So how does that help you? Well, if you're going to get the variance, sigma squared, you need NPQ. So the variance is going to be, because we just talked about what it's the complement. Q is the complement of P. Your variance, N is 10. Little p is 0.25. Q, or the complement of p, is 0.75. So I'm going to get the variance. But why do you need the variance? Because the standard deviation is the square root of the what? Variance. So my standard deviation, which was the question, is the square root of 10 times 0.25 times 0.75. Now, again, ladies and gentlemen, you may not think that this is a big deal. It is a very big deal, because look at the definitions we used yesterday. All I got to do now is use what? Square root 10 times 0.25 times 0.75. Approximate that to the nearest thousandths. That's 3, 6, what? 9, ladies and gentlemen. So the binomial has shortcuts for the mean, the variance, and the standard deviation. Enjoy the shortcuts. So if you didn't do any binomial homework over spring break because you were in Fort Lauderdale, or you were in where? Maui, or you were in where? Where'd you guys go for spring break? Work? Do you guys know what I mean? If I were you, I'd get started on some binomial homework, because what's the story? You got these shortcuts you can use, because they're going to ask you shortcut questions. How to get the mean and standard deviation. And if you don't believe me, let's take a look. So remember, this is from the notes. And I even went through some examples. You don't have to do this table. The reason I did this is to show people you don't got to do the table now. You ain't got to do that. Well, let's go back. You go, what was the homework? You guys remember the binomial? Look at problem 7. What does problem 7 say? Or according to a college survey, 22% of all students work full time. Oh, did you work in spring break? Anybody here work full time? Maybe. Some people work full time. I was a full-time student. Sometimes you got to work. You got to work full time. Look at number 7. What are they saying? This is a binomial homework question. 22% of students work full time, right? Find the mean for the number of students who work full time in samples of size 16. What? So they're like saying, guess what? You're selecting how many students? 16. What's the probability that a student works full time? 0.22. Is that true? And then what do they want me to do? They're saying find the what? Find the mean? Well, this isn't the binomial homework. Again, publishers are just, they hire relatives to write this stuff. They don't hire mathematicians, ladies and gentlemen. They find the cheapest person they can find to write a question, and they don't even do it right. Sorry about that. They should have had more information. They actually made it so simple. It's like unbelievably simple. They said, here, n is 16, p is 0.22. Find the mean. Oh, it's binomial. Mean is, mu is np. What is n? 16. What's little p? 0.22. Here we go. 16 times what? 0.22. What do you got? It was 3.52. So you might say to me, how does this kind of work and feel? Why are you finding the mean of this distribution, right? Because what they're saying, if you know for a fact that 22% of college students are full-time students, if you had a class of 16 people, what could you expect in terms of being full-time? 3.52 students should be full-time work full-time. I'm sorry, did I read that correctly? Yeah, work full-time. That's not being a full-time student, but work full-time. Okay, and that kind of sounds right in all honesty. You know, so if you had a class of 16 students in which 22% are work full-time, they're not full-time students, they work full-time, then you can expect that 3.52 will be what? Full-time students. Now, this is a mean, this is an average. Just because you have a class of 16, you might count. You go, know what, Mr. Judge? We did a survey and we found that it was only 3 students, not 3.52. Well, again, this is an average. This is a summary. There's a chance there's only 3. There's a chance there's only 4. There's a chance there's none. But the mean of the distribution is 3.52. So that's what I'm saying. You have homework questions like this on that worksheet. Anybody finish that homework? Okay. Well, what if they asked you for the what? Ooh. You're going to wait till the night before? What do you guys think? You say, Mr. Judge, I do better under pressure. People tell themselves that. You imagine if you're getting married. You know, I don't want to imagine that, man. That's kind of like a bad. I don't even want to go there either. Oh, God. You know, don't even imagine that one. Imagine you're getting married and you got your dress. Anybody ever watch that Say Yes to the Dress? I used to watch that with my daughter, and I used to laugh like crazy. I used to love that show, Say Yes to the Dress. You guys know, I used to watch it with my daughter when she was young. You know what would happen? The guy would tell the bride, don't get a dress smaller than your size. Because some of these brides, what would they do? They get a dress much smaller. And what would they say? I'm going to get in this dress. This will force me to. You guys know what I mean? And what would happen? The night before the wedding, the bride is in tears. Why is she in tears? Because she can't get in her own dress. You guys know what I mean? It's no different for the bride. You could be a groom and you want to get in that tuxedo. I'm going to look good for that wedding. That's the kind of stuff I do. Like I say, I'm going to go to Maui this summer. Oh, I'm going to get swim trunks too small. Because I'm going to get in those trunks by summer. I'm going to force myself to. Doesn't happen. So you got this funny guy walking around with trunks that are too small. And that's me. So it's not just ladies. It happens to guys too. We do that too. It's kind of a true story. I won't walk around in trunks too small. I'll just wear my other ones that are not too small. I don't want to leave you guys with that visual. But what if they asked you for the variance? I'm sorry, standard deviation. Swim trunk story. You guys don't think that way too? You guys don't do it that way? Am I the only one? Man, sometimes I feel very lonely. I'm the only guy that thinks that way? No? I'm going to get in those trunks. Then when you can't get in, it's pretty small. It's pretty sad. So I understand, but I used to watch that show, and some of the brides were like kind of in tears. Anybody want to tell me, how do we get this? What was N? 16. Good. What's little p? 0.22. And then you get 1 minus 0.22. Okay. Yeah. Say yes to the trunks. Second square root, you're going to put what? 16 times what? 0.22. You know what I can do? I can put a parentheses and put a 1 minus 0.22, and I could close that. And ladies and gentlemen, there you go. What are you going to get to the nearest thousands? 1.65. What? 7. And that, ladies and gentlemen, is how quick, easy, and fast you can get the mean, variance, and standard deviation when you're in the binomial distribution setting. So these are shortcuts for the mean, variance, and standard deviation, and they only work for binomial. You say, what if they didn't give me the binomial? Well, remember yesterday? Where are you guys? Oh, here we go. This is the formula you would use for the mean. And this is the formula you would use for the what? Variance and standard deviation. So when you do the regular homework, statistics lecture 9, and then now when you do statistics lecture, what number? 10. I can now change this in Canvas to assignments to